Okay, let's have a look at how we go about converting from mass, which we can measure, to moles and moles to mass. Now to do this, we've got to take this concept of 1 mole being equal to 6.022 by 10 to the 23rd particles. And that's known as Avogadro's number. So we say the atomic mass, or what we can actually measure, for any element contains Avogadro's number of atoms in any element, and is defined as the molar mass if we measure the mass of that particular number of atoms. So to determine the molar mass, we change the units that we have on our periodic table, which are known as atomic mass units, and they're a comparison between the mass of the total mass of the protons and neutrons, atomic mass units, to grams. So we can do this because we assume when we're talking about 1 mole, or the molar mass, we're always talking about Avogadro's number of atoms. So let's take an example. Let's say I have titanium, and its relative atomic mass, measured in atomic mass units from our periodic table, is 47.867. 1 mole of titanium, so 6.022 by 10 to the 23rd atoms, will be equal to 47.867 grams of titanium. And we compare this with carbon-12. So let's apply this to a question. We're asked how many moles in 5 grams of sodium. To calculate this, we've got to divide the number of grams that we're given, 5 grams, by the molar mass for sodium. And to do that, we look in our periodic table and we find that it's 22.994 grams per mole, or grams for 6.022 by 10 to the 23rd atoms. So we do this calculation and we get the number 0.217. Our grams cancel, and so we get this as the number of moles. So in 5.00 grams of sodium, we have 0.217 moles of sodium. Now the previous example only looked at an individual element. We can also apply this to compounds. So we're asked the question, what's the molar mass of carbon dioxide? And to do this, we need to calculate the molar mass of the individual components of that compound. So the molar mass of oxygen is 15.9994 grams. And our molar mass for our carbon is 12.0096 grams. To calculate the overall molar mass of carbon dioxide, we need to add the individual molar masses for the elements that are contained within that compound. So we have 1 lot of carbon, 12.0096. We actually have 2 lots of oxygen, so we need to multiply the molar mass of oxygen by 2, so 2 times 15.9994, which gives us a total mass of 44.0084 grams. And this is the molar mass of carbon dioxide. So we can calculate molar mass from our periodic table quite easily, but we can also calculate the number of moles of any given substance given the molar mass of that particular compound. So let's take an example. Let's say we want to know how many moles of hydrogen chloride or hydrochloric acid there are in a 25 gram sample, or 25.0 gram sample. We need to go through 2 parts. First of all, we need to calculate the molar mass of hydrochloric acid, and to do that we use a similar process to what we had up top. We have 1 lot of hydrogen, 1.008 grams, plus 1 lot of chlorine, 35.45 grams, which gives us a total of 36.46 grams per mole as the molar mass of our hydrochloric acid. But that's not the end of our question. We're asked in the question, how many moles of hydrochloric acid do we have in a 25 gram sample? And to do that, we need to divide our 25 grams by our molar mass, so 25.0 grams divided by 36.46 grams per mole, which will give us 0.06857 moles. So our question asks, how many moles of HCl do we have in 25 grams? We have 0.6857 moles.